Hello everyone, and this is Venu, and you are watching C programming videos. And today class it is about bitwise operators, operator precedence rules, and typecasting. And these are the topics we are going to discuss. So coming to the first one, bitwise operators here. So already we discussed various types of operators. So coming to the bitwise operators, the bitwise operators are bitwise AND, bitwise OR, XR, one's complement, one's complement, left shift, right shift. All these are the bitwise operators. So all these are bitwise operators. So in the case of bitwise operators here, bit generally, what is bit? Bit generally it is 0 or 1. So if you represent bit, the bit is only 0 or 1. So while we are working with this bitwise operator means indirectly, okay, indirectly, if suppose we are working with the numbers means internally the numbers are converted into like bits, uh, that is 0 or 1. So we should convert. Suppose if you are working with any numbers means should be converted into some binary form. So it is in terms of zeros and ones. Okay. And let us see first of all, what is mean by bitwise and how the bitwise and bitwise or bitwise XR will work here. To see the working of these operators here, to see the working of this operator. So first of all, I have to explain about bitwise AND. So almost it is similar to the logical AND, but in the case of logical AND, we are dealing with the expressions. But in the case of bitwise, we are dealing with bits, that is 0 and 1. So observe here, if inputs are both the 2 or 1, then the output will be 1. In the remaining cases, the output will be 0. That's all. If both the input A and B is 1 only, output will be 1, and remaining cases it is 0. And this is the working principle of bitwise AND. So the resultant, if both the two inputs are 1, then resultant will be 1. Other cases 0. And what about AR? What about bitwise R? In the case of bitwise R, in the case of bitwise R, in the case of bitwise R, if any one of the input is 1, okay, if any one of the input is 1, the output will be 1. So observe this case here, 0 and 1. 1 is 1. So that is why output will be 1. 1 0 1 and 1 1 1. And remaining cases it is 0. Remaining cases it is 0. Okay. And what about the XR? XR is it is the special case. That means when inputs are different here, when inputs are 0 and 1, output will be 1. Inputs are different, 1 0, output will be 1. And the remaining cases it is 0. Remaining cases it is 0. So inputs are different, output will be 1, and inputs are same means output will be 0. And this is the working of the bitwise AND, bitwise OR, and here XR. So let us see the examples of this here, bitwise AND, OR, and XR. And if you see the example of these three, so I have to declare a variable 10, and B is some 3 I am taking. Now just have to write here a percentage A and B equal to some percentage T comma I'm writing A and B. Similarly, I have to write bitwise AND or XOR. Okay, bitwise OR and XOR is its caret symbol. Now I am replacing it with this, and it is with OR. Okay, so OR is one single pipe symbol, AND is one single AND. So I don't want to exclude this code here. Directly I have to tell the output first of all. See, if I am giving these inputs to the program, so 10 is my input. So I have to represent this 10 in the binary form. Okay, like a 8-bit representation, 4 zeros, 1 0 1 0 I am writing. Similarly, I am representing 3 as 4 zeros, 0 and 0 1 1. Okay, and now see, if these two are positive numbers, so that is why the MSB bit indicates, this bit indicates here the MSB bit, these two indicates here. If it is this MSB bit 0 means the sign is positive. If MSB is 1 means the sign is negative. Okay, anyway, I'm giving these two are positive, so that is why I'm taking MSB is this, and both the two are numbers are positive, that is why I'm taking here MSB bit as 0. Now I want to perform, I have to perform the operations. What are the first operation we have to perform? Apply the AND between, bitwise AND between these two. Okay, so if I am applying AND means, what is the output here? 0 and 1. 0 and 1. If I am giving these two input 0 and 1 to the AND means 0 and 1, 0, 1 1 1, 0 0 0, 1 0 0, and remaining cases you will get all zeros here. Again I am getting MSB bit is 0, that is why resultant is positive, and it is equivalent to 1 0. What is the 1 0 equivalent to decimal number? 2. So that is why this answer is 2 here. Okay, the first answer is 2. Okay, then what about R? And see, if you see in the case of R, 0 and 1, 0 and 1 means 1, 1 and 1 1, 0 0 0, 1 0 1, and remaining cases all zeros here, remaining cases all zeros. So 1 0 1 0 1 1. What is the equivalent of 1 0 1 1? It is 11. So this answer is 11. Okay, it is 2 and it is 11. And what about XR? In the case of XR, if I am giving 0 and 1, inputs are different. 1 1 1 0 0 0 0 1 0 different. So now remaining cases, it is all zeros here. It is all zeros. So now 1001 is nothing. 1001 is nothing but 9. So the equivalent decimal number will be 9. So answer is 2 11 9. These are the answers. So I am commenting here. This is 2 and it is 11 9. So let us see the verification here. I am getting all results are correct or not. So now A and B is 2, it is 11 and it is 9. Okay. Otherwise, I have to separate all these expressions with a new line. Now build the program, build and run. Now you will get 2 11 9. Yes. So our analysis is correct. So this is the working principle of the AND or XR operators. Okay. And once If it is finished here, see the ones complement. Okay, ones complement is nothing but negation. So here I am giving a formula. I have to give the formula here. If we find out any ones complement of the number, if suppose n is the number, the ones complement of a number n is minus of n plus 1. Okay, so that means I have to find out, suppose a equal to 5, and I have to calculate here negation of a. It will be what? Minus of 5 plus 1. So it is equivalent to minus 6. So it is equivalent to minus 6. Okay. So indirectly, this minus 6 is, it's nothing but here. The minus 6 generally, if you see, the minus 6 is nothing but it is the 2's complement form. Okay. So always in C language, the negative numbers are represented in 2's complement form. So I will explain this hmm, with the correct example. For the next slides, I will explain this. So how we represent negative numbers hmm, in the coding. We will see that also. Okay, anyway, so in this scenario, here if I found any ones complement of the number, I am getting here minus of n plus 1. See, I am taking here 10. So minus of 10 plus 1 will be what here? Minus 11. Suppose if I am giving negative number, so minus of minus 15 plus 1, it will be the 14. Okay. So if you want to verify this, hmm, so like I'm taking a equal to 10 and some b equal to minus 14 I'm taking it. Okay, minus 14 I'm taking. Now what I'm doing, I have to perform here percentage t. Okay, negation a is comma negation a I'm writing. Similarly, I can also write here negation b. Negation b equal to this negation b. That's all. So negation of a means what here? It is equal to minus of a plus 1. That means minus 11. And what about the negation of minus 14 here? So minus of minus 14 plus 1. So it is minus 13. Minus minus plus. So 13 is the answer. So now build the code, run the code. You will get minus 11 and 13. Okay. So this is hmm, the negation operator bitwise. Okay. And once if these four are finished here, the remaining is left shift, and another one is right shift. So what is mean by a left shift? Left shift means shifting the number of bits to the left side and assigning that many number of zeros to the right side. So even though we are shifting either zeros or ones, irrespective of zeros and ones, the alignment right side is number of zeros are assigned. Okay. Then what about right shift? Right shift is similar here. We are doing the shifting the bits onto the right side and assigning the number of zeros onto the left side. That's all. Okay, let us see the example. I have to give one example. Suppose I am giving my input is 10. If I am giving a input is 10, so I have to shift 2 bits onto the left. I am shifting 2 bits onto the left. So that means we are shifting the bits onto the left side means, so here left shift is bitwise operator. That means it is working with the zeros and ones. So that is why I have to represent this 10 in binary format like this. Okay. So how many bits we have to shift here? 2 bits. That means I'm removing this, and now after then it will be like this. Okay. And how many bits we have to add here? 2 bits. 2 bits we have to add. So if we are removing means we forgot about those bits here, but we should assign some zeros onto the right side. Now it will become like this: 0 0 0 0. This is MSB bit. So 0 0. So after doing the left shift, you will get the numbers are like this here. Okay. So now anyway, this is my MSB bit. If it is 1 means result is positive. And now convert this thing into the decimal format here. So it is 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 3 into 1, it is 8. 2 power 4, 0. 2 power 5. 2 power 5 into 1 is 32. 32 plus 8, 40. So now 40 is the answer. What is the answer? Okay. And then what about right shifter? What about right shifter? So in the case of right shifter, see I'm taking again my input is 10. I'm taking input is 10. I have to shift 2 bits onto the right side. That means again I have to convert it is into some binary, and I have to shift the 2 bits onto the right side means we are removing this. And how many bits we have to assign here? 2 zeros onto the left side. So now tell me, after doing the shifting here, you will get the output like this. Okay. So how many zeros here? 6 zeros, 1 zero will come. Now tell me what is the equivalent decimal number of this here? It is 2. Okay, it is 2. Okay. Now, so I have to give some common formula for left shifting and right shifting. And what is that formula? See, if you are doing, if number is n and you are doing m is the number of shifting bits, then the formula is this. Okay, n into 2 to the power of m. So if you are shifting m bits to the left side for the number n, then the formula will become n into 2 to the power of m. Okay. So in the previous case, I am taking a equal to 10. Okay. And I am taking b equal to 2. That means we are doing this left shifter. It's nothing but we are shifting the bits on 2 bits onto the left side. And then what is the formula? Number is 10 is multiplied with 2 power. It is multiplied with 2 power. M is what? 2. Then it is equivalent to 2. 10 is 2 square means 4. It will be 40. Yes, in the previous case also, I got the same answer 40. Now, this formula is correct. And what about right shifter? What about right shifter? Just you have to divide. In the previous case, 2 power m we are multiplied, but in this case, we have to divide with the 2 power m. So if I am doing right shifter means what? Again, my a is 10, and I have to shift the bits, 2 bits onto the right side. Then the formula is like this here. Where shifting onto the right side means the number divisible by 2 power 2. It's nothing but 10 by 4. So both the two are integers. So 10 by 4 means what? You will get only the quotient value. What is that? 2. So now for the both the two cases, I got the same answer. So that is why our analysis and these two formulas are worked properly. And let us see the final verifications. I'm getting the same answer or not. If I'm compiling, if I'm taking the same inputs like a equal to 0 and I'm taking b equal to 2, I want to do printf percentage. So I'm writing here first left shifter, which is equal to percentage t comma left shift. And similarly, I want to take here right shift. That's, and after this, I'm giving a slash. Just compile the code and run the code. So I'm getting, yes, left shift is 40 and right shift is 2, correct. So this is hmm, the final one. Here after compilation of your program also you got the same answer. Okay, so finally, uh, so this is the concept regarding bitwise operators. Okay, now I want to give here, I want to give some more examples. So if you are working with these bitwise operators with the negative numbers, okay, so that is the, if positive numbers means we can represent in the bit form, it is easily here. But what about if suppose input is negative numbers means the analyzation it is difficult. That means what, first we should represent the number in two's complement form, and then after then we can apply the same logic. So that is why, so here what I am doing, okay, here what I am doing, if suppose, if suppose I am taking a number 2, if I'm taking a number 2, we can represent into some 8-bit form. Like this indicates here 0 means it is the positive. Okay. But I have to represent minus 2 means what? So this MSB bit will become 1. Then it is minus 2. Then it is minus 2. Okay. But see, while we are implementing this negative numbers, in the case of C, if you are working with these negative numbers, all negative numbers are represented in 2's complement form only. So 2's complement form. Hmm. So now, 8-bit representation of 8-bit representation of 8-bit representation of plus 12 is this. Okay. So I want to represent in a, we have some forms, sine magnitude form, sine 1's complement. Sine 1's complement is this, and sine 2's complement. So see, observe, for all the, for positive numbers, all representation are so, same here. So that is why we don't bother about in the case of positive number. All representation are same. But what about if the number is negative? Okay, if the number is negative, here we have to do some modifications. So what are the modifications? See, so my intention is that I want to represent minus 12. So if you represent minus 12 means what, generally we should, this is the 1100. Generally, if it is positive 12 means what, how we express this here? 4 zeros followed by 1100. But in the case of sine magnitude form, it is replaced with 1. So that is why I'm writing okay. And what about sine 1's complement? Sine 1's complement means what? We have to keep this digit here MSB as it is and changes remaining bits zeros to 1. 0, 1, 1, 1 and 0, 0, 1, 1. Okay. And what about 2's complement? Similarly, in the case of 2's complement means just we have to add one more 1 with the 1's complement, then you will get the 2's complement. But the thing is that, and in this scenario also, the MSBBD is as this, it's not modified. See, after getting this one's complement, just I am adding this one, and I'm adding here 1 plus 1 is 1 0, and again 1 plus 1 is 1 0, and 0 plus 1 is 1, and this is the answer here. So I'm doing binary addition here, then I will get a sine 2's complement. So now for the case of negative numbers, for the case of negative number, sine magnitude form is different, sine 1 is different, sine 2's complement is different. Okay, so this is the important observations while we are working with the negative number. See, already, hmm, okay, so now most of in the case of minus 12, in the case of negative number, I should represent it in this sine 2's complement form. Okay, so this is the needed one, and it is okay, based on these only we will get this representation anyway. So you know the awareness of these two also. Hmm? Okay, so here what I am doing here, In all the format, MSB is fixed and it is not modified. So one's complement is changing zeros once, and two's complement is add one at the unit place. Okay. Now after doing this, I'm giving the example here. See, if I'm taking an example like this, I'm taking A is 10 and B equal to minus 12, and I have to apply the same logic for bitwise AND. Then in this scenario, see, it is minus 2. Minus 2 means I have to represent this in 2's complement form. Okay, 2's complement form. Then apply the AND operation. Then apply 0 and 0 is 0, 1 and 1, 1, 0, 1, 0, 1, 1, 1, and remaining cases are all 0, 0. Okay, anyway, 1, 0, 1, 0 means you will get 2. Then how I get here? The minus 2 equivalent to this value. See, the sign magnitude form of this minus 2 is this. So basically we have 4 zeros, 0, 0, 1, 0. But I have to represent this as 1 means what? It is sign magnitude form. Okay. And sign 1's complement means you have to keep this one as it is. Then 0, 1, 1, 1, 1, 1, 0, 1. Okay. And what about 2's complement? Add 1 with this and you will get 2's complement. Okay. So finally we can get here the 2's complement form representation, and that only we have to do. Okay. And in the previous scenario, see, in the previous scenario, so I'm getting here. So I have to give one example. What is my example is, see, minus 6. So I have to represent minus 6 equivalent to 2's complement form. So I'm taking here 6. Generally 6 means what? 4 zeros followed by 0, 1, 1, 0. Okay. Now I have to represent into magnitude form 1, 0, 0 and 0, 1, 1, 0. Okay. And then I have to represent it into one's a complement form here. So 1, 1, 1, 1, 0, 0, 1. Okay. Now if I'm adding 1 at unit place here, if I'm adding 1 at unit place, then I'm getting mm, so then it is 1 and it is 1, 1, 1. Okay, anyway, it is also 1. Next 0, 1 plus 1, 1. Now 0 will come. So this is the form I am getting here. So now the minus 6 equivalent to 2's complement form is this. Okay, let us verify. See, if I am giving A is some 5, then I am getting negation A is equal to negation A equal to I am getting minus 6. Okay, negation A equal to minus 6. Let us verify. If suppose A equal to it is 4 zeros, hmm, after then 40 101 I am giving. So if I am giving negation A means what? Just we are changing. Negation means changing zeros into ones into 0. So now 0 can be changed to 1, 1, 1, 1 and 1, 0, 1, 0. Now see, it's nothing but what? This form. So now here both the two are same. So this is what here? Minus 6. This is minus 6 here. So now indirectly here minus 6 is the answer, but minus 6 can be expressed in which form? 2's complement form. Okay, 2's complement form. Okay. And once if it is finished here, okay, once if it is finished, the next concept is precedence and associativity of all the operators. That means what? See, generally we have the techniques called, okay, we have some techniques called BODMAS. Okay, we have some techniques here, BODMAS. So generally BODMAS is what? So if an expression first it is start having bracket is first simplified, next off, next division, multiplication, addition, subtraction. But suppose here that is about in the case of mathematical. But suppose if we are working with, suppose in C we have several types of operators. So that means what? If suppose if an expression is consisting of all these operators, you need to know which operator is executing first. Which operator is evaluated first. Is it the evaluations takes from left to right and right to left? So that is must. So that is why the president's rules are came into the picture. Okay, and let us see. So here operator, the description, and precedence level and associativity. So see the first these are the operator: parenthesis, square bracket, arrow, and a dot. So these are having the highest priority. And how they are expanded? It is from left to right. Okay, left to right. Okay, so that means what? If suppose if we are having an expression that consisting of these operators means these are expanded first. Similarly, if suppose remaining these plus unary minus, increment decrement operators, exclamatory, ampersand star, data type size of, and these are having the second priority. But how they are simplified? It is from right to left. Okay, the expressions are uh, uh, these are evaluated from right to left. Hmm? All unary operators, increment decrement operator along with this. So like this you can also see the remaining operators. Okay, and this is the third priority. Next to arithmetic operators. Hmm? So in the arithmetic operators, multiplication, division, modulus having first priority. Next addition, subtraction. Similarly, left shift, right shift. After then, logical operators, equal, not equal. So like this. Hmm. So we can observe here left to right. All are evaluated from left to right. Only only some are expanded from right to left. Okay, so and or all these are, hmm? So what are the operators expanded from right to left here? See, ternary operators and assignment operators, these are expanded from right to left, and all unary operators. Okay, so I have to show once again. See, and these operators, these are evaluated from right to left, and remaining these two, and except these three, and remaining are evaluated from left to right only, left to right only. Okay, so conditional operators, that is ternary, and assignment operator, and all unary operators are expanded from right to left. Okay, I have to give some example related to this. See, my expression is like this. So if I am simplifying this, that means plus and star is simplified first, and this is added with the a, you will get the output 36. So 5 5 is a 25. 5 into first a, 5 6 the 5 6 the 30, 30 plus again a is 6, so 36 will come. Okay, and what about the second expression? And in this scenario here x equal to y, and if you simplify this here first, modulus. Okay, so evaluation from left to right, huh? So first it is simplified this, and after then multiplied with this, next simplified this, and next addition and subtraction having the equal priority. Now first simplifying this, and after then we are adding. So like this you will get x equal to 17 and 58. And what about ternary? So in this case first, see, so logical or is there, so a less than b, so 9 less than b, and 9 is less than b, is it true? Yes. And b less than c, is it 15 less than 16? Yes, true. Hmm? True or true, true. And overall this represents some, hmm, positive one, any positive non-zero value. But it is true, the not of true means false. Not of true means false, but it is what integer type. So always 0 represents here false, 1 represents true. So that is why e value will be 0. Yes. And what about f? And what about f? F means what? Yeah. If a greater than b, this means ternary, a greater than b, 9 greater than 15. Is it true? No. If it is true means what? This is evaluate b minus a. B minus a means 15 minus 9. 15 9 minus 9 means 6. Answer is, so by this way you will get the answer. Okay. And this is about here ternary mm, operator examples. Okay. And finally, I have to give one conclusion here. See, so when you are working with the two integer numbers, the resultant is integer only. And if you are working with into float, resultant is float. Float into float, 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 float. Say I'm giving 5 by 2. You will get both the two are integer. Okay, you will get 2. But I want to expect here 2.5 means I want to expect 2.5 means either you have to do some typecasting like this float of x of 5 and divisible by 2, then only you will get here you will get a 2.5. Okay, 2.5. So now if your operands, one is decimal and another one is float and one is integer, means float is the answer, and integer by float, float is the answer. Both the two are float, float is the answer, but both the two are integer, integer will become the value. Okay. And now, so the last session, the last concept in this session here, that is typecasting or type conversion. So actually what is mean by typecasting here? Okay, so we have basically the type conversions is divided into two types, implicit and explicit. So again it is classified into this. Okay, it is not required here, so just have to explain about first the implicit and explicit type conversion. So here in this case here, see, if an expression, the data type of one operand is converted into the data type of another operand. Okay, operand to get a uniform type, and that is called type conversion. That is so implicit type conversion, generally sometimes the compiler automatically it can convert one data type of one to another one, that is implicit type conversion. And the implicit conversion example is this automatic type conversion. So automatic type conversion means so while we are dealing with the characters and short if you are converting in integer type, okay, so if you are doing any conversion here, automatically it is converted into the integer type. See, already we are observed in the case of ASCII, if you represent a character into its ASCII, automatically it converted into the integer. So that is automatic unary conversions here. Automatic unary conversion. I'm giving the example here. See, first I am taking x equal to y, it is integer, I am taking float. So I have to assign this 5 to the y. Then we are assigning 5 to the y, but y is the floating type. So that is why you will get 5.0. You will get, so I am using format specifier percentage of, you will get 5.0. So it is, we can add here lower data type directly into the higher data type. No issues with that, is automatic type. And what about here float x equal to 5.2, but we are at, it is int is y and we are adding x into y. In this case also you will get but only the integer type. Here we lose some data, here we lose some data, like we are not getting the complete 0.2 here, we are getting only integer type. It is also typecasting here, implicit typecasting. So we are not doing any manually, I'm not performing any forceful operations between the operands here. Automatically the compiler itself is converted, so that is why it is automatic typecasting. It is implicit typecasting. Okay, then what about explicit typecasting? And what about the explicit typecasting here? This is the explicit typecasting. So in this scenario, we have to use this uh, expressions like this here. Between the parentheses, use some data type. See, I'm giving one simple example here. X and y values are integer, so I'm taking two float values p q, and p equal to x by q means what? It will be 5 by 2 means I'm getting only the quotient value. So I'm getting here first, we are converting 5 by 2 means what? You will get 2, and 2 equivalent to float value will be 2.00 something. Okay, but see, I want to get the complete. I don't want I want to get the complete output, like the decimal value. That means either you can change the x as 5.0. So how I represent 5.0? Just I am adding a float of x by y. Then you will get the actual value, and that is here explicit type conversion. Otherwise, I have to show the exclusion here. See, so I'm taking here int a equal to 10 and b equal to some 3 I'm taking. Okay, so I have to take another two numbers call. Okay, mm, and the cd I'm taking here. So first c I'm writing here a by b. Okay, and d equal to, just I'm writing, first of all I have to convert a into the float type. Okay, float a and divisible with b. So now here what I am doing here, so before we are doing this operation, I have to convert a into the float type. So now it will be some 10.0 something. So now here in the case of the first one, percentage f comma, I'm writing here c. In this case here, so in this case first a by b means what? A by means, uh, I'm putting comment here, 10 by 3. 10 by 3 means you will get only the quotient. 10 by 3, 3 value will come. So the 3 equivalent to float number is what? 3.00 something I am getting. And what about in this scenario here? So we should convert first 10.0 is divisible with 3. So 10.0 is 10.00 something. It is decimal by integer. Then you will get decimal value. Okay. So just I am compiling and run the code. So now see what I'm getting. Then I'm getting the complete data. We lose some data. Okay, if we are not doing explicit type conversion, but with the explicit type conversion, I get the total data. So that is the concept here. See, explicit means manually we are forcefully convert the data type into float. After then we are doing the operations. Implicit means automatically it convert. Already this is integer, but we are converted into float type. That's all. Okay, so this is the difference of here implicit and explicit typecasting. Okay, here I'm giving some examples, like I'm taking characters, integer, and the float types here. I can convert character into the some h, and float into some integer, and float into some f1. Like if I'm writing I1 means what? I1 is it is we are converting a float 80.56 into the integer means 80 can assign. Now the equivalent 80 ASCII equivalent character is assigned in the place of C2. So like this, we can perform for the remaining operations here. Okay, so like this, we can perform here. We can convert integer to float, float to integer. So all these are what here? All these are implicit type conversions. Implicit type conversion. So finally, the conclusion is what we have. two types of conversion, implicit and explicit type conversion. And explicit is this. The explicit example is this, and this is the implicit here. So actually uh, we are doing the operation between the integer, and again int can be converted into the float type. So now the float value is this. Here we lose some data, but in the case of explicit we got the mm, exact output. Okay, so this is the explicit type conversion. Okay, thanks for watching.